Hey guys, we'll just give everyone another minute or so to join. We'll start in a minute. Okay, so why don't we go ahead and get started? And if we have any late stragglers, they can just go ahead and join. So yeah, uh, so I'm Solomon. I'll be going over your USACO problems today. So let's go ahead and jump right in. So let me go ahead and share my screen. Okay, so the two problems you guys were supposed to work on for today are USACO 2018 December, bronze 2 and 3. So 2 is the bucket list and 3 is back and forth. So we can go ahead and start with the bucket list. So I'm gonna go ahead and read it out loud and then explain the
몰라, 뭐
problem.
제가 한것 같아. 들어본 적 있어.
Um, I'm gonna go ahead and okay. So let's go ahead and start. Okay. Farmer John is considering a change in how he allocates buckets for milking his cows. He thinks this will ultimately allow him to use a small number of total buckets, but he is not sure how many exactly. Please help him out. Okay. Farmer John has N cows, and N can be between 1 and 100, conveniently numbered 1 through N. The ith cow needs to be milked from time S to time T of I and requires B of I buckets to be used during the milking process. Several cows might end up being milked at the same time. If so, they cannot use the same buckets. That is, a bucket assigned to cow I's milking cannot be used for any other cow's milking between time SI and time TI. The bucket can be used for other cows outside this time window, of course. To simplify his job, Farmer John has made sure that at any given moment in time, there is at most one cow whose milking is starting or ending. That is, the S sub i's and T sub i's are all distinct. Farmer John has a storage room containing buckets that are sequentially numbered with labels 1, 2, 3, and so on. In his current milking strategy, whenever some cow, say cow I, starts milking at time S sub I, Farmer John runs to the storage room and collects the B of I buckets with the smallest available labels and allocates these for milking cow I. Please determine how many total buckets Farmer John would need to keep in his storage room in order to milk all the cows successfully. Okay, so the input will be from a file called blist.in. The first line of input contains n, which is the number of cows. The next n lines each describe one cow containing the numbers s of I, t sub I, and b sub I, separated by spaces. Both s sub I and t sub I are integers in the range 1 to 1000, and b sub I is an integer in the range 1 to 10. Okay, and the output is going to be in a file called blist.out, and it's output a single integer telling how many total buckets Farmer John needs. So we can run through the sample input, always a good habit. So here we have 3 cows, n equals 3. So each line describes one cow. So cow 1 needs to be milked from time 4 to time 10. That's S sub I is the first letter, the first number, T sub I is the second number, and then B sub I is the last number. So B sub I is the number of buckets it needs to be milked, right? And then cow 2 needs to be milked from time 8 to 13 with 3 buckets, and cow 3 needs to be milked from time 2 to 6 with 2 buckets. Okay, so how do we get 4 buckets total as the answer? So Farmer John needs buckets 1 and 2 for milking cow 3 from times 2 to 6. He uses bucket 3 for milking cow 1 starting at time 4. Okay, so once we hit time 8, cow 2 arrives, so this middle cow here. And then buckets 1 and 2 are now available because they finished being used with this bottom cow, but not bucket 3 because bucket 3 is still being used on cow 1. So he uses buckets 1, 2, and 4 for because he needs 3 additional buckets for cow 2. So the immediate thing I think of when I read this problem is I think we can create almost like a number line to try to visualize the problem. So if I go ahead and annotate, so we have this, oops, let me undo that. Okay, that's a little better. This timeline, right? So we'll make this our timeline. We'll label it T for time. And we can go ahead and put the times. So put 0 here, put 2 here, 4, 6, okay, 8, and 10. Okay, so this is our timeline right here. And we can go ahead and label each cow and how many buckets they need, right? So we'll call this first cow, cow 1, the second cow, cow 2, and this last cow, cow 3. And I've labeled them on the left. So if we go ahead and kind of draw, like overlay the cows on this timeline, right? So we can start with, let's go chronologically. So cow 3 first, right? So cow 3 goes from time 2 to time 6, right? So that's from here to here, right? This is cow 3, and he needs, or the cow needs 2 buckets. So I'll just put a 2 there. Okay, and then what about, what's the next cow, right? So the next cow is cow 1 from time 4 to time 10. So I'll put that underneath right here. From time 4 to time 10, right? So cow 1 needs 1 bucket. So I'll put it right here. And then cow 2 is the last cow, right? So cow 2 needs to be milked from time 8 to time 13. So I actually missed that. Say 13 is over here, right? Okay, so let's draw cow 2. So cow 2 is going to be over here, right? And how many buckets does cow 2 need? Cow 2 needs 3 buckets. Okay, and so almost like automatically, right? If I were to ask you okay, how do we calculate the maximum number of buckets we'll need at any one time? Your gut instinct would be to say, okay, let's go ahead and just add all these numbers vertically, like this, right? At each time along this timeline, and at whichever point we get the biggest number, that's how many maximum buckets we're ever going to, that's the maximum number of buckets we'll ever need, right? And you'd be exactly right. So if we go ahead and add all these numbers at every single time, time 0, time 1, time 2, all the way down, right, the timeline, you get that at time, we'll just go over the important ones, right? So from time 4 to 6, right, we get 3, you need 3 buckets because it's 2 plus 1. Okay, from time 6 to 8, you need 1 bucket. From time 8 to 10, you need 4 buckets. And then from time 10 to 13, you need 3 buckets, right? And so out of these numbers, and I guess we can also go from 2 to 4, right? It's 2 buckets. So out of all these numbers, which one is the biggest? It's 4. And that's why our answer is 4. And so we're going to use the exact same approach in our coding solution, right? It's literally going to be the exact same as what we just did. We are going to, once we take in the input, we're literally going to create a timeline, right? And this time it'll be an array. And so what we could do is create like a new array and, put in each cow's like time. But instead of doing that, what we're actually going to do is put all this into one array. So all the cows will put into one array. And then as we go through the input, we'll go ahead and add, like each time frame's cows, like each cow's time frame into the array. And then we'll basically just, however many buckets it needs, we're gonna add that to the position in the array, right? So if I go ahead and erase what I drew, and so I'm gonna redraw the same thing, right? But this time it'll be a little more like coding friendly, right? So this, instead of a timeline, right, we have an array now. So this will be our array, right? And this is this was our timeline, right? So let's say this is, we'll just do cal3 because it's the easiest to draw, right? So this is index 0, 1, 2, 3, 4, 5, 6, right? So from time 2 to time 6, right? Cal2 needs 2 buckets. So remember how when you start in an int array, everything starts at 0, right? So literally as we go down each line of input, we're going to add, right, this B number from this S to T time. So basically we're going to fill all of these spots with 2, right? Because cal3 requires 2 buckets, right? And then as we go through the input and then add more and more cows, right? We're gonna start adding like a +4 here and like a here and here, you know? And then we're gonna start overlaying all of these like different cows, like how many buckets they need, right? Like this, for example, let's just say. And then by the end, right, we'll get one place in the array with the biggest number, and that's gonna be our answer. So now that we understand the problem, all we have to do is code it. So I'm gonna go ahead and share my Eclipse screen. Let's see. Okay. So let's go ahead and code this, right? So you can see I've already done a little preliminary work here. As usual, right? You need your main method, throwing your IO exception, also your init and solve with the IO exceptions. Inside your main method, we're gonna create your input, the way you're gonna grab your input. So this time we can use a scanner. We also have a print writer for the output file, right? And then this is just standard, typical scanner notation and print writer notation. Make sure you call both of your methods, and then make sure you close both your in and your out. You can see here I've made some variables, right, which will help us out. So we have N, S, E, B, and A, which are all pretty much defined in the problem, right? So here I just said E is like T, right? It's ending time. And then we have our A array for our timeline, right? So we can go ahead and start coding, right? So the very first number in our input is going to be the N, right? It's going to be the number of cows. We'll just say N equals in.nextInt. And that's going to be N. And then we're going to initialize our new array, right? So it's going to be an int array. And technically they say the times can go from 1 to 1,000. I'm actually going to make my array from 1,001 length long, just so I can, I don't have to worry about doing the -1 every time I want to put something into an index, because indexes start from 0. So like if cal3 went from time 2 to 6, I can just say at time 2 to time 6 instead of at time 1 to time 5, right? So then our very last index will be at time 1,000, right? So we don't have to worry about the -1. So that's really all it is for the init, right? Pretty simple. And then so for the solve, the solve is pretty simple. Also, we just have to create a for loop, right? And this for loop is going to go from 0 to n. Right. And so you can see that so far for our input, we've only taken in the first number n, right? We still have to take in all of the rows. And so that's what this for loop is doing. Technically, you could have also done this for loop in the init method. Doesn't really matter, right? So we take in 3 numbers on every row, right? So we take in an s equals in.nextInt. We also take in an e, the ending time. You can also say t, right? And we also take in a b. So those are the three numbers you take in on each line. And then we can create another for loop, right, to add these numbers. Remember, add the B number, how many buckets you need for that cow, into the A array, right, from index S to index E. That's really all it's going to be, right? So int J equals S, J is less than or equal to E, J plus plus, right? And then all you want to do is say A at J plus equals B, like that. And then at the very end, all you have to do is, all we have to do now is find the maximum value inside the A array, right? And you could look, you could go through the array and look for that number, or we can just sort the array, right? Both work. I'm gonna sort it just because it looks nicer and it's easier. And then at the very end, we just have to print out the biggest value in A, right? So how do we do that? Well, the biggest value is gonna be at the very last index, index 1000. Okay, and that should be our answer. So I'm going to go ahead and show my browser and we can upload this together. So let's go ahead and run this. Let's see if it works. Okay, perfect. So that is bucket list. I think bucket list is honestly on the easier end of bronze problems. So yeah, it's good practice. Okay, and then back and forth. So this is our next problem. Farmer John has 2 milking barns, each of which has a large milk tank as well as a storage closet containing 10 buckets of various sizes. He likes to carry milk back and forth between the 2 barns as a means of exercise. On Monday, Farmer John measures exactly 1,000 gallons of milk in the tank on the first barn, and exactly 1,000 gallons of milk in the tank of the second barn. On Tuesday, he takes a bucket from the first barn, fills it, and carries the milk to the second barn, where he pours it into the storage tank. He leaves the bucket at the second barn. On Wednesday, he takes a bucket from the second barn, possibly the one he left on Tuesday, fills it, and carries the milk to the first barn, where he pours it into the storage tank. He leaves the bucket at the first barn. On Thursday, he takes a bucket from the first barn, possibly the one he left on Wednesday, fills it, and carries the milk to the second barn, where he pours it into the tank. He leaves the bucket at the second barn. On Friday, he takes a bucket from the second barn, possibly the one he left on Tuesday or Thursday, which is important, fills it, and carries the milk to the first barn, where he pours it into the tank. He leaves the bucket at the first barn. Okay. Farmer John then measures the milk in the tank of the first barn. How many possible readings could he see? So the input file will be backforth.in, output file will be backforth.out. The first line of input contains 10 integers, giving the sizes of the buckets initially at the first barn. Initially. The second line of input contains 10 more integers, giving the sizes of the buckets initially at the second barn. And this is important, all bucket sizes are in the range 1 to 100. For the output, please print the number of possible readings Farmer John could get from measuring the milk in the tank of the first barn after Friday. Wow. Okay, so the sample input, 2 lines here, right? This first line is the line, is the bucket capacities, right? All initially at the first barn. Second line is bucket capacities, all initially at the second barn, right? 10 buckets each. And then we want to output the different number of possible gallons in the tank of the first barn after Friday, right? And so going through the sample input, the answer is 5. And why is it 5? So they kind of explain it over here. So these are the 5 possible readings, right? 1,000, 1,003, 1,004, 1,007, and 1,008. And so 1000 is because if he just carries the same bucket back and forth, right? Then the first barn's milk level will remain unchanged. 1003 is because he can carry, so I'm just going to draw this out really quickly. You have the first barn and you have the second barn, and he literally makes 2 trips here, right, which are Tuesday and Thursday. And he makes 2 trips here on Wednesday and Friday. Because Monday he just uses to fill up the tanks. So he makes 2 trips to barn 2 and 2 trips to barn 1, right? So 1000 means he carried the same bucket back and forth, right? So no change. 1003 means he carries 2 units on Tuesday, 5 units on Wednesday. So after Wednesday, milk barn 1 has +3 units of milk. And then Thursday and Friday cancel out, right? Whether it's 1-1 or 5-5, right? Thursday and Friday cancel out. 1004 is if he goes 1 unit on Tuesday, 5 units on Wednesday, so it's a net +4 for barn 1. And then Thursday and Friday cancel out, whether that's 1-1 or 5-5. 1007 is because he can carry 1 unit on Tuesday, 5 units on Wednesday, so +4 net for barn 1, and then 2 units on Tuesday and 5 units on Friday. So that's another net +3 for barn 1. So that's 1007. And then lastly, 1008, he can carry 1 on Tuesday and then 5 on Wednesday. So that's a net +4, and then 1 on Thursday and 5 on Friday. So that's another net +4. So overall, you get net +8. Okay, so we can like take a look at how we just solved that sample input, right? We literally just went through pretty much every single case. And so the way you want to solve this problem is literally by brute force coding it. And a hint you can get in the problem to see that there's no like there's no hidden like trick or something like in the other problem, is because you can see that it says all bucket sizes are in the range 1 to 100. It's just a little hint that like there's going to be a lot of computation involved, right? That's why they keep the constraints on the input size kind of small. They're not going to make these bucket sizes, super big. You kind of just want to brute force code this entire problem. And the way we're going to do that is we are basically going to, let me go ahead and clear my annotations. All we really want to do, right, is count the different number of values, right? Like how many different values do we get from all the trips Farmer John takes, right? Each of his 4 trips. And so we're literally going to use like a double for loop, right? To calculate, okay, so he can take this bucket on Tuesday and then take this bucket back on Wednesday. And then, okay, that one's kind of redundant. Like other than he uses the same bucket every time, right? We're literally going to calculate, okay, he takes this bucket and then this bucket and then this bucket and then this bucket, this bucket, literally all the way through, right? And then we're literally going to start the next one, this bucket, and we're going to calculate every single possible combination on Tuesday, Wednesday. And then for each of those Tuesday, Wednesday combinations, we're going to calculate it again for Thursday and Friday. So it's literally going to be a Tuesday, Wednesday for loop, double for loop, right? And then inside each Tuesday, Wednesday combo, we're going to calculate a Thursday, Friday combo, which is like another double for loop, right? And then we're literally calculating every Tuesday, Wednesday, Thursday, Friday combination possible. And we're literally going to toss all these numbers into, so how do we calculate, what data structure have we learned that'll keep track of all the different numbers, all the different things we have, right? So if we have all of these results that we have to keep track of, right? We want to use a hash set, right? We want to use a set because sets do not store duplicates, right? So we're going to have one value for each unique value we have. And so at the very end, we can just grab the set.size, right? And we'll have our answer. And so that's literally how we're going to solve this problem. We're going to brute force the entire thing, right? There really is no hidden pattern or algorithm, or if there is, and you can find it, that's great, right? But not really what you need to solve this. So I'm gonna go ahead and share Eclipse, and then we can go ahead and solve this. Okay. And so just a little setup, right, that you guys all should have. Main, init, solve. I will say, so for the variables, I created several variables. So an A array, a B array, an A1 array, a B1 array, and an n equals 10 array, right? And the reason why is because the A1 and B1 arrays are going to be to store the initial arrays that we have, right, of all the numbers. And then the A and B arrays are arrays we're going to change, right? Because as Farmer John goes back and forth, he is going to leave his bucket, right? Possibly leave his bucket. And so the A and B arrays, we're going to change every time. We're going to like swap the value of the bucket he takes with him. And then that's going to be for each Tuesday, Wednesday, Thursday, Friday combo. And then as we calculate each combination, we're going to reset the arrays, right? A and B. So that's why we just keep a duplicate. So that's why we have A1 and B1, right? Just to reset the arrays each time. So we can go ahead and do the init. And so we have the first two numbers we're going to get are A and B, right? So we say A equals new int n, B equals new int n, right? Because if you remember the input, it looks like this, right? Okay. And so you want to say A1 equals new int. Oh, and n is 10, by the way, just so we know, like just so we're clear, right? A equals, A1 equals new int n. And B1 equals new int n. So these are all just size 10 long, right? Nothing too complicated. And then we want to use the for loop, right, to go ahead and initialize our arrays. So from 0 to n, keeping in mind n is 10, right? They told us that in the problem. So a at I equals in.nextInt, and a1 at I equals a at I, right? We're just creating our duplicate array. And then we want to do the same thing for the B arrays. Just like that. So now we've set up A, B, A1, and B1, right? So that's all our setup, basically. So we can go ahead and go into the solve. So for the solve, we said we wanted to create a hash set, right? To keep track of all of our different values, right? So we're going to go ahead and create a hash set. Okay. Once we create our hash set, we want to use the quadruple for loop to keep track of every single possible Tuesday, Wednesday, Thursday, Friday combination, right? And so here we're going to start with a double for loop for the Tuesday, Wednesday combos. Right, so it goes from 0 to n because there's 10 possible Tuesday bucket combinations. We're going to have an inner for loop, j loop, right? It's also 10 long to keep track of all the Wednesday combinations. So I'll just note it out. So this is Tuesday, Wednesday, like that, right? And then inside, once we're here, let's calculate the milk after Tuesday, Wednesday. That's inside our first, like our barn 1 milk tank, right? So I'll call it first, and it's going to be equal to the default value is 1,000. After Tuesday, we're going to subtract A at I, right? Because A keeps track of all the bucket capacities, and we're taking a bucket on Tuesday from barn 1. And then on Wednesday, we're adding a bucket from barn 2, so, right? So we go minus A at I plus B at J, right? So after Wednesday, this is gonna this int first is going to be the value of the milk we have stored in our first milk tank. And we're going to need that, right? Because now, after Tuesday, Wednesday, we're going to go ahead and swap A at I and B at J, right? So how do we swap? We say int temp is equal to A at I, and then we'll say A at I is equal to B at J, and then we'll say B at J is equal to 10, just like that. So now we've swapped A at I and B at J. And then once we swap, we want to do Thursday and Friday, right? So we'll add 2 more for loops. I'll use K and M. Right, and this is going to be Thursday. And this is going to be Friday, right? And so here we want to pretty much do the exact same thing, right? So int result is equal to A, right? A keeps track of, it's going to equal to first minus A at K plus B at M, right? And this just basically means after Thursday and Friday, our result variable is going to be keeping track of the milk in our first milk tank, right? So first is how much milk we have after Wednesday, and then minus A at K is going to give us after Thursday, plus B of M will give us after Friday. Remember, the A array holds the buckets at the first barn, and then the B array holds the buckets at the second barn. And remember, we also swapped a value in A for a value in B after Wednesday because we're accounting for what happens when Farmer John swaps 2 buckets, right? Remember, when he leaves a bucket, he leaves a barn 1 bucket at barn 2, and then leaves a barn 2 bucket at barn 1, right? So that's why we swapped those. Okay, so we made our result variable. This result, we really just want to add into this hash set, right? So like that, because after Friday, this is the amount of milk that's going to be in barn 1. And then after each Tuesday, Wednesday, Thursday, Friday combination, we want to reset A and B, right? And the reason why A equals A1.clone is because this is like one Tuesday, Wednesday, Thursday, Friday combination, right? We need to go ahead and calculate every single Tuesday, Wednesday, Thursday, Friday combination. And in order to do that, we have to make sure that we don't contaminate the arrays, right? So we have to refresh basically the arrays that we use. Okay, and then once we finish all of this, all we have to do is print out the size of answer. And we should have our answer. So let's go ahead and run this. I will share my USACO screen. Okay, let's see. And let's see how it goes. Oh, okay, let's see. Oops. Okay, so, it looks like I outputted answer instead of answer.size, so I'm gonna go ahead and fix that. Okay, so let's go ahead and resubmit. Yep, perfect. Okay. So let's go ahead and see. And yeah, so just to clarify on an earlier statement, right? In terms of coding the actual problem. So a hint, you can kind of tell that there's no special hidden pattern or trick. to this problem, right? There's no like special algorithm or something like the last problem. So I said that like it's the bucket sizes. It's actually not. It's actually like the fact that like there's only like two barns, for example, and the fact that like there's only um 10 possible buckets and there's only 4 possible days, right? Because you can already see there's only 4 days, two barns, and 10 buckets per barn, and we've already used like four for loops. And so you can already see that like our code because our code like brute forces everything. It's gonna take a long time and it's gonna get exponentially longer, right, and more intensive if there's like more buckets or especially like more days he takes a trip, right? Like what if he goes on like Saturday and Sunday, or what if he goes for like a few weeks at a time, right? Suddenly we're gonna have like a bunch of loops, right? Or if we have like a bunch of buckets, it's our loops are going to take a really long time. And so because the problem is like so constrained, you can kind of tell that like um, your code is going to have to be like pretty intensive. And so that's kind of a hint you can use to be like, okay, I could probably just brute force code this problem, right? Scenario by scenario, and I'm not going to run out of time, right? My code will be able to finish in time. And so yeah, that's basically back and forth. And we also covered the bucket list. So since we finished a little early, right, 40 minutes, for the remaining like 5 minutes or so, I can go ahead and go over questions. Yeah, I'll go back to the code right now. Hang on. So this is the code for, here, I'll just show the two methods. So this is the code for the third problem. Yeah, and so I can go ahead and take any questions. And so again, like a general strategy for USACO problems, especially USACO bronze, is like once you read the problem and you understand the sample input and output, it's really important to like kind of like look at your own brain as you solve the input and output. Like take like a looking glass, look at your own brain and like figure out what am I thinking, what steps am I taking to solve this problem. Um, and so if your gut doesn't automatically like jump out at you saying, "Hey, there's a pattern I can use," and sometimes you might just have to make a series of steps. Okay, like this is what I do, like step one, step two, step three, and then once you have those series of steps that work for a bunch of different inputs and outputs, then you can go ahead and code it, right? Coding becomes a lot easier when you know exactly what you're trying to code. Coding becomes a lot harder when you don't really know what you're like trying to code. You don't really know like what the answer is, like you don't really know where you're going, right? So like take a paper and pencil. That's what I always did, like literally scribble out, like draw stuff out, like make your game plan first and then follow that game plan when you code, and it becomes 10 times easier, right? So yeah, I'll leave a minute for like any questions people have, or if anyone wants me to go back to the other problems code, just go ahead and ask. So I'm looking at chat right now. Any questions? Yeah, for sure. So I'll go, so here's the top of the code. And so why do I do A equals A1 dot clone, right? And that's because, again, so let me go ahead and draw. So I clone A and B because let's say Farmer John does his Tuesday and Wednesday trips, right? So let's say he does his Tuesday trip first. So on his Tuesday trip, right, Farmer John goes here. And then he potentially drops off a little bucket, right? And then on Wednesday, he's gonna come back to the first barn and potentially leave another little bucket, right? And I'll make this bucket a different color, right? And so after Wednesday, right, Farmer John potentially has switched buckets, right? This bucket and this bucket. So this blue bucket is originally from barn 1, and this pink bucket is originally from barn 2. And so what we do in this code is we basically say for every Tuesday and Wednesday scenario Farmer John does, right? We are basically assuming that he swapped buckets. And then once those buckets are swapped, we run every possible Thursday, Friday scenario with those swapped buckets, right? And so if you have like these 10 different possible buckets, right? I just drew like a little array grid here, right? Imagine these are all the bucket numbers, the bucket sizes at barn 1, and these are all the bucket sizes at barn 2. After we calculate one Tuesday, Wednesday, Thursday, Friday combo, right? We have to reset the buckets at each barn because we need to go ahead and like change combinations, right? We need to check the next Tuesday, Wednesday, Thursday, Friday combo, and we need to make sure that we don't like leave the buckets swapped when we check the next combination, right? Or else we're just messing up the entire array. So that's why we do a equals a1 not clone, because a1 is like remember when we first started the problem, we made a and b, right? And we also made a1 and b1, right? And we said a1 and b1 were going to be our arrays to keep fresh copies of a and b, so that after every single, after we check every single 4-day combination, we can basically reset a and b to be fresh arrays so that we can check the next combination, right? We don't want to be contaminating these arrays over and over again as we check each next combination, basically, is the idea. So that's why we refresh. We're like resetting the arrays, basically, as we check each combination. And that's the idea there. Okay, so if there's no more questions, guys, I think we can call it a day here. So good luck coding these. Thank you guys so much for coming today. And I'll see you guys next time. Thank you, guys.